Happy New Year to everybody. Happy New Year to Flip Spiceland, too, who's at the Weather Center now. Flip.
Happy New Year to you folks. We have not exchanged those pleasantries yet this millennium, have we?
But we've been a little busy around
We have been indeed. Let's take a look at our map. We'll start in the United States. Jonathan earlier mentioned that this is the weather for the first day of the millennium. We realize some of you watching, it is already the second day of the new millennium. We'll try to work our way around the globe to you. There's a little bit of rainfall in the Great Lakes area expected this evening, but what is significant about that is that it is rainfall, not snowfall. Here we are in winter in the U.S. and talking about rainfall in the Great Lakes, not snow. Snowfall in the mountains of Arizona today. A weather system rolls in through western Canada, producing some snowfall in Washington and Oregon, some rainfall here in the coastal areas. But the big news in North America, and really the northern hemisphere in general, the very warm temperatures, particularly so in the southeastern portion of the United States. There is an influx of cold air sliding down through the western U.S. We move on now to the European continent, where really most of the bad weather has been, but that has been dwindling away. This storm system came rolling across yesterday. Perhaps if you were watching our live coverage, you saw a few showers across London, but again, that storm weakening somewhat. And then another cold front is stretching across the British Isles. It'll bring some clouds into Scotland and Ireland. We look now at our forecast for high temperatures, and again, relatively warm for this time of year throughout all of not just Europe, not just North America, but all of the northern hemisphere. And of course, in the southern hemisphere, it is summertime. So we're looking at an area of high pressure bringing typical summertime weather to Rio and Montevideo too. Widely scattered showers and afternoon convection throughout the Amazon River Valley. Here's a look at your forecast for high temperatures. Rio will see a high of 30 on the Celsius scale, 86 Fahrenheit. Buenos Aires up to 31 on the Celsius scale. Have yourself a wonderful first day of the new year. In some places, the second day. Now back to Natalie.
Thanks, Flip. Next on Millennium 2000, the race to complete the most complicated map in the world.
They are mapping you, and it will change your life. We'll have that next.
And now, a simple question for everyone who is...
Man has mapped much of the world around him and is now focusing some of his most exciting exploration inward. Medical trailblazers are taking on a huge challenge. They are mapping human DNA to discover what makes us who we are. As CNN medical correspondent Eileen O'Connor explains, unlocking these mysteries could open a Pandora's box.
Francis Collins is a government scientist. Craig Venter used to be a government scientist. They prefer different modes of transport, both recreationally and scientifically, but both are racing towards the same goal, mapping the very stuff that makes each of us unique, our DNA. Collins sees the mapping of the human genome, as it is called, as an end in itself.
This is, in fact, our most significant adventure in science as a species, reading our own blueprint.
Venter as merely a beginning.
People talk about this being a race all the time. This is a race to the starting line. You've heard Francis Collins and others say this is the most important thing that science has ever done, more important than going to the moon. I don't agree with that. I think it's important, but what will really determine its importance is what all of us do with this information.
It is information detailing every aspect of our very existence, and each of us has a unique and total accounting. Inside every cell in your body is a nucleus that contains a complete set of DNA, twisted within 46 chromosomes. Unravel those and you get a long, double-stranded thread. That's the DNA. Within that are some 80,000 genes that tell each cell which proteins to make. It's those proteins that determine what a cell will be, what it will do, and how well it will do it. In other words, those bits of DNA called genes direct our cells. They determine whether our eyes are blue, our hair is brown, or our skin is black. Those same genes also determine whether our cells will function normally or not, whether we will get sick. For instance, there is a gene that determines how well the body processes cholesterol, and therefore how likely you may be to suffer from blocked arteries. Scientists believe they have found genes in animals that control appetite and hunger signals to the brain. That gene clearly plays a role in how much people tend to eat and how fat they may get. It's the DNA in the gene that will determine if a person's brain cells will malfunction, creating the conditions for a disease like Alzheimer's. 4 chemicals make up the DNA in our genes that tell the cell what to do. Scientists have assigned them 4 letters. A is for adenine, T for thymine, G for guanine, and C for cytosine. A always pairs with T and G always pairs with C to form that double strand of DNA. How those letters are sequenced or ordered determines each person's unique DNA, the letters of our own book of life.
To the biologist, this is it. This is the book of life. This is where all the secrets are going to be found if we can figure out how to read that code.
But merely reading the code is no easy task. There are 3 billion of these lettered pairings in the human genome. Not all of these pairings make up genes. To map the human genome, government labs are taking DNA from an anonymous donor and looking at it line by line, letter by letter.
To read it, you have to do a chemical reaction.
That chemical reaction forces the 4 chemicals that make up the DNA chain, A, C, T, and G, to identify themselves through color. To do this, Collins' team cuts the DNA into tiny fragments, then clones or copies them, which is what is happening on these plates here. Only after that are the copied DNA snippets treated with special chemicals and gels. Each chemical letter of the genetic code reacts differently to the chemicals that have been added. The reaction creates different colored beacons on all the snippets that are then fed into the computer and read.
And you have to load it onto the sequencing machine, which are gadgets like those over there and others in this building that actually then produce the data, which is a series of colored fluorescent signals coming off the bottom of a gel.
The green is A, the blue is C, the red is T, and the yellow is G. So I bet you could even read that genetic code now. So there's...
Yeah, so what was green?
Craig Venter is using a similar method, but he is mapping the DNA of 5 donors at once, instead of just one person's, piece by piece, as Collins is doing. He believes his method is faster and will yield better information for doctors through comparing the DNA of each donor.
So you can see each one of those little tiny colored bars is one of the letters of genetic code. So this is the human DNA from one of our genetic donors here.
Can it be just one of those little letters that can cause a disease?
Just one of those differences. See that green A there? If that ended up being a blue peak of a C, that could be contributing to the cause of a disease, or the difference between having dark hair versus having no hair.
Funded by private companies, Venter vows to finish the human genome by next summer.
With all these robots, we can pick over 12,000 clones an hour. And each of those spots has one piece of the human genome in it.
Oh my God, this is incredible. There's how many computers are here?
If you just look down here at the hundreds of machines working, each one generating thousands of letters of genetic code automatically every hour around the clock.
Yeah.
You can see why we've been able to get over 80% of the human genetic code starting in September 8th.
300 machines costing some $300,000 apiece. That's $90 million. Added to this supercomputer, the biggest in private hands, makes this a costly venture.
This computer facility would be enough to run any country in the world.
Still, Venter says they are spending far less than the $3 billion the government has budgeted.
We have found ourselves in a circumstance of being able to say it's doable faster than you thought, and it's costing less than you thought it would.
Francis Collins likes to brag even to scientists at the Baylor College of Medicine in Houston, who are part of his team, that the government project is also under budget and will now bring in a working draft this spring, well before their earlier deadline of 2005. That means the government's new projected completion is the same as Venter's. Yet Collins denies that Venter's entry into what neither likes to call a race has moved up the target date.
Help me with the whole problem of patenting genomic sequences.
But Collins does tell doctors at Baylor that Venter's practice of filing preliminary patent applications on some 6,500 DNA sequences so far has spurred him on. Doctors are concerned about this issue of who owns the right to the information in each decoded sequence. Their worry is that protracted legal battles will slow down the research necessary to achieve medical therapies.
A lot of the really interesting experiments are not going to be one gene at a time. They're going to look at the whole genome. And if we start putting up barriers to that, we're going to slow down the process. So hence our motivation for taking the stance we have and for hurrying up, trying to get it all out there in the public domain.
The government is trying to make this information public domain by posting it immediately on its website, updating every 24 hours as the sequences come off the machines. These kinds of patent applications have become increasingly common. The U.S. Patent Office says ultimately it will be up to the courts to decide whether anyone other than mankind can own a piece of the human genome.
The court system will find that medium for us, and I think the system itself will find that medium for us. I think our position is that genes and ESTs are patentable so long as they meet the legal requirements which have been laid down.
Venter's company called Celera has its own website, open to paying subscribers, mostly pharmaceutical companies for now. While Venter is protective of trade secrets, meeting at times behind closed doors, he says patents aren't about protecting secrecy, that they are the only way to protect and provide the motivation for pharmaceutical company partners to spend the millions needed for further research in developing drugs from this knowledge.
Patents are the means that give the pharmaceutical industry a reasonable period of protection to invest the billions of dollars they have to develop new drugs.
Bill Hazeltine is also a firm believer in patents. He is using them to generate investment money in his company, Human Genome Sciences. Hazeltine is already developing drugs based on some of the genes from the human genome. Drugs like VEGF2, which can grow new blood vessels in heart patients, alleviating closed arteries, and a kind of second skin, a plaster applied to an open wound to accelerate the healing process. But unlike Venter, he does not believe mapping the entire human genome is all that useful.
What the Human Genome Project will uncover is 90%, 97% junk DNA. And the parts of the genes they'll find are genes we've already found.
Instead of decoding all the DNA, Hazeltine has been looking at just the genes and how they function. That's only about 5% of the total DNA. By doing that, he says he is moving more quickly towards these kinds of drugs that harness the healing power of certain genes. He says mapping the entire genome is nice, but shouldn't be the first priority.
It is a good scientific infrastructure project, but it is not immediately applicable to medicine.
Both Collins and Venter see it much differently.
The part in between the genes, much of it will be involved in regulation, in telling a gene whether it's supposed to be on or off in your liver or your blood cell. So we really need to understand the parts that aren't in the genes themselves if we want to understand risks of disease and how to manage them.
Venter says by being able to compare our differences throughout the entire genetic code, doctors will be able to develop individualized drugs to treat disease.
So the pharmacy in the future will base the drugs that you get based on your genetic code, so you don't get ones that could be toxic to you. Right now, that's done totally randomly. We don't know who it's going to work on and who it won't. That's the biggest thing that's going to change in the future.
Doctors will also be able to predict what disease, like heart disease and certain kinds of cancer, a person may develop later in life, which could be used to help patients prevent those illnesses. Trouble is, it could also be used against individuals as a reason to deny someone employment or health insurance.
I feel very strongly that you're the only one that should own your genetic code. We want that to empower individuals, not empower companies or governments.
Collins preaches much the same thing. He too thinks before this genie is let out of the bottle, Congress must act and pass privacy laws.
This vision of gene-based medicine can only come to pass if the public becomes confident that finding out genetic information is a safe activity for them.
That isn't Francis Collins' only concern, for it is clear that reading nature's genetic blueprint will allow man to alter nature's intended plan.
Genetics is enormously powerful to give hope to people who currently don't have that hope, because we don't understand their diseases and we don't know what to do for them, and ultimately that's all of us. But it also is possible for this kind of knowledge to be used in ways that we would all recoil from, and collectively, I think, as society, we're responsible for trying to make sure that that doesn't happen.
Venter again agrees. The time is now, he says, to set up the parameters before the power behind this knowledge is unleashed.
It's not the knowledge, it's not the technology, the tools, the computers. It's what we believe as society is moral and what we're going to do with this information. So this is the time to have the discussions.
Eileen O'Connor, CNN, Washington.
It's amazing stuff, and our look at this remarkable research poised to change all of our lives continues with Dr. Craig Venter.
We will ask him what he's learning about us and how he plans to use that information when we come back.
The discovery of DNA was made by James Watson and Francis Crick in 1953.
Proliferation of discoveries about the genetic contributions to diabetes and heart disease and high blood pressure and schizophrenia and multiple sclerosis and on down the list. The most immediate consequences will be diagnostics, where you and I can find out, if we wish to know that information, what our own individual risks are for future illness. Those will not be precise risks that say, oh, well, you're going to get this disease on your 45th birthday. But they will be relative risks. And they will be very useful for many of those circumstances where we have good ideas about how to reduce the risk if you know what disease specifically is lurking there in your DNA.
Thousands of diseases that can damage the quality of life or cut life short have genetic components. Once those genes are identified, medicine will have made the first crucial step toward a cure.
Understanding human genes gives us a powerful set of new tools to address medical problems, either to create new chemical drugs to treat diseases, or to use the genes and the substances they make, proteins, as medicine themselves.
I think by 20 years from now, gene therapy will have revolutionized medicine. Every major disease will have gene therapy as a treatment option, and millions of lives will have been saved.
In gene therapy, malfunctioning genes are replaced by healthy ones. The healthy genes are delivered into the cells of various organs using a virus. The main challenge has been to find a virus that safely carries the healthy genes to the right cells. Sometimes the virus misses its target or creates side effects in the patient. Researchers are still trying to determine what killed 18-year-old Jesse Gelsinger. Gelsinger, who had a rare liver disorder, died in September at the University of Pennsylvania, where he was participating in a gene therapy trial. That death placed a caution light on further trials, but researchers remain optimistic that gene therapy will save lives in the 21st century.
In the longer term, these gene discoveries will lead us to a whole new level in terms of drug development. And we will have therapies, both drug therapies and gene therapies, for diseases that we currently don't successfully treat.
So does that mean we will someday look back on breast cancer or Tay-Sachs the way we now look back on polio?
I think that we are 10 to 20 years away from that happening. It will happen. We will get over our current difficulties, and we will have ways to change genetic destiny.
But genetic diseases are only one category of disease. Experts say one of the greatest threats to humanity in the 21st century will be an increased frequency and severity of infectious diseases and superbugs.
There's always the threat of a new and emerging epidemic, and those of us in the public health field are particularly concerned about the capability of the influenza virus to emerge in a deadly fashion, as it did in 1918, where it caused over 20 million deaths worldwide and up to 750,000 deaths in the United States.
Since its discovery, 16.3 million people have died from AIDS. Although the spread of the disease has been stemmed in many parts of the world, it is decimating Africa. 69% of the 34 million people infected with HIV worldwide live in sub-Saharan Africa. In the United States, 60% of hospital infections are caused by drug-resistant microbes, which kill 14,000 people each year.
A classic superbug is a multiple drug-resistant Staphylococcus aureus. Another superbug is a multiple drug-resistant tuberculosis. So you give it the terminology superbug when it has overcome man's attempts to suppress it by what we usually suppress them with, namely antimicrobials.
Over the past 2 decades, over 30 new and emerging infectious diseases have been identified in humans. Hantavirus, a virus spread by rodents, infected over 50 people. More than 2/3 died. Last summer, the West Nile virus mysteriously appeared in the U.S., where it had never been seen before. It was carried by birds from New York and spread to the southeastern United States. Certainly, the shrinking world has made it difficult to contain infectious disease. As human beings have become more mobile, millions of us traveling from continent to continent and shipping our livestock and food around the world, the natural barriers that used to contain disease have become irrelevant, broken down by ships and airplanes. Disease travels too.
The fact that we live in a global community where there's travel back and forth, where you can have someone be in Africa one day and be in the west coast of the United States literally the next day, or in certain countries in Asia and go around the world, that means that any infection or any disease in any part of the world can be transmitted to another part of the world under any certain circumstances.
So what hope do we have to contain or cure these kinds of diseases? Hospital infections could be dramatically reduced if hospital staff were more vigilant about hand washing. The CDC and NIH are currently working on new vaccines for AIDS and other infectious diseases. But new hope may once again be found in genetics.
If we know the sequences of their genomes, then we'll have a basic blueprint of their genetic code, and from that blueprint we'll be able to understand how that organism can live or cohabit in our bodies.
The ultimate goal, of course, is to wipe out all diseases, to never again see a child struggle with muscular dystrophy or leukemia, a man in his 60s lose his mind to Alzheimer's disease, a teenager die randomly from a mysterious bacteria or virus. The dawn of the 21st century finds us closer to that goal than we could ever have imagined. But hope can brighten or dim depending on where you live. The quality of health care around the world varies wildly. As medical science advances, there is no doubt new cures and treatments will be discovered. The next challenge will be to distribute them to everyone who needs them. Dr. Steve Salvatore, CNN, New York.
We're going to pause briefly here, but when we come back, 21st Century Solutions, a conversation with experts from the World Health Organization, the Centers for Disease Control, and Human Genome Sciences about the breakthroughs that are happening and the ones that lie ahead. Stay with us.
In the last decade, more than 50 new viruses were identified.
Oh, I feel like I'm 18 again.
Yeah, me too. You'd think I'd feel awful after blowing our retirement money.
What?
Yeah, it's gone.
All of it?
Yeah, I decided to invest our money by myself.
What are we gonna live on?
Hey, fresh air, sunshine, what else do we need? You know, money is highly overrated.
Next time, don't go it alone. Ask your financial advisor about the fund so many financial experts choose. Alliance Capital, the investment professional's choice.
The Goodwill Games are coming to TNT. Chevy Trucks proudly presents the world's best.
People that do mogul skiing are fun-loving people that like to push themselves to the extremes. Going into the jumps is always a little scary because you got this big thing in front of you that you're just throwing your body off of. It's a crazy feeling. You're just like, ooh, I'm way up here. You have to have a pretty low fear factor so that you dare push the speed, you dare try new stuff. It can be really scary.
The 2000 Winter Goodwill Games, where the world's best prove it. Coming in February to TNT.
20 years now. Where'd they go?
Need help with those?
I can do it. 20 years. I don't know.
I mean, you just caught an edge. It happens.
I sit and I wonder sometimes.
Year after year, it's good to have someone you can depend on. Chevy Truck. The one the U.S. ski team depends on.
Well, when I got hurt in this work, thought I had supplemental insurance.
Supplemental insurance? What's that?
Aflac. Well, even best insurance doesn't give you cash to cover things like lost pay, other expenses. This does.
What does?
Aflac. Shouldn't ask about it at work.
Really? And what's it called?
Aflac!
Aflac. Without it, no insurance is complete.
Aflac!
In the past 25 years, the average life expectancy has increased by 9 years.
The Human Genome Project that we've been talking about today holds out an amazing prospect. Science has found the instruction manual that explains every cell in our species. Doctors just don't understand it yet. But there is progress there, and there is progress of many kinds elsewhere as well. We're going to talk about that now with three guests. From Southampton, New York, William Haseltine, who appeared in our preceding report. He's founder and CEO of a company called Human Genome Sciences. Joining us from Geneva, Switzerland, Dr. David Heymann, Executive Director of the World Health Organization's Communicable Diseases Cluster. And from here in Atlanta, Dr. Jeffrey Copeland, Director of the Centers for Disease Control and Prevention, the CDC. Doctors, we thank you all for being with us. Let's start with you, Dr. Heymann in Geneva, but I'm going to invite everyone who's here with us, and Natalie here on the set with me, to jump in if you have a thought or two. Dr. Heymann, where are the real medical miracles today? Where are the breakthroughs being effected? Where are the extraordinary cures that excite people like you?
Well, the cures and the tools necessary to prevent infectious diseases are with us today. What we have to do is muster the political will and also the financial support to use these tools better to stop the infectious diseases which are occurring worldwide.
Jeffrey Copeland, the point is well taken. Money matters, but it's also a question of science and of scientific success. Where are the big successes now?
I think we're seeing one right now around the world in our efforts for polio eradication. Dr. Heymann and his organization are leading the way in this. But we expect by the end of next year to have eliminated polio as a scourge around the world. This involves both the scientific know-how to do it, which we have, public health will, and as Dr. Heymann said, the political will to get it done.
Why don't we go now to Southampton? Dr. Haseltine, you're working on a whole new kind of drugs. Are we about to see a whole new kind of medical care because of them?
Yes, we are. And in answer to your first question, 1999 has been a breakthrough year for medicine. We've seen an unprecedented explosion in our knowledge of infectious diseases at their most intimate level, the level of their complete gene sequence. We have a very accurate blueprint of human genes, and that knowledge is now seeping through our universities, our pharmaceutical companies, the biotechnology companies, and we are witnessing a true revolution in the making. That's not to underestimate the importance of distribution of current medical practice throughout the world. We're in great need of the World Health Organization, surveillance of the CDC, and distributing what we now know. We can make a much healthier world just on what we know today, but the future is even more exciting.
I'm struck by what you're telling us, Dr. Haseltine, because we've been talking about gene research for an hour now, and you sound like the most optimistic voice that we're hearing from.
Well, I'm extremely optimistic based on the knowledge that we have. We have actually taken some of these breakthroughs and have them in patients, human beings, being treated right now with some of these genomic breakthroughs. We're trying to restructure and regrow blood vessels in the human heart to make coronary bypass surgery irrelevant. We're trying to heal the skin of patients with these chronic wounds that don't heal. We're trying to shield the body from the devastating effects of chemotherapy. Those are things that are happening today. And we also hope very soon to be introducing new drugs to stimulate the immune system to help fight off some of those infections that are resistant to antibiotics. So I'm extremely optimistic about the near term as well as the long-term future, as long as we have the right medical infrastructure, not only in the developed world, but in the developing world as well.
Quick follow-up on that point, the future, Dr. Haseltine. This is Natalie. You have said in the past, and I quote, "Death is a series of preventable diseases." That said, and with this research and your optimism, let's talk about life expectancy in the next 100 years. Where could that go?
Well, first of all, let's start with the last 100 years. In developed worlds, life expectancy is just about doubled. We're now living, on average, twice as long as people born in the last century. And I think the next century can add another 50 or 60 years to the average lifespan. So the average person can live a full natural lifespan of 100 to 120. And I think eventually we can do better than that. But for now, I think we can keep our sight on bringing everybody's longevity up to those of us who can live the longest, which is about 120 years.
Let's go to Geneva, because once again, I'm struck by the different voices that we're hearing. One doctor who says that technology and research is really going to change everything, and other voices that say technology really isn't the answer. Is there nothing on the research front? Is there nothing that gene research, Dr. Heyman, offers the kind of people and the kind of diseases that the WHO is seeing?
Well, I'll come back to what I said earlier. We do have the drugs and we do have the vaccines today to get rid of the majority of infectious diseases. Infectious diseases today are very unequally distributed in the world. If you look in low-income countries, you'll see that of all the deaths that occur in those countries, 45% are still due to infectious diseases. If you look at the population which is economically productive, those people under the age of 46 years of age, you'll find that of those dying, 48% die of infectious diseases. And 90% of those deaths are due to 6 infectious diseases: tuberculosis, malaria, diarrheal diseases, pneumonia, measles, and AIDS. Diseases for which we have vaccines or good drugs or preventive measures. So we must better use those tools and get rid of infectious disease deaths today.
While we hear about these very serious threats and these terrible diseases, authorities in the United States can take pride in the fact that many of these diseases were in the U.S. and were essentially cured, weren't they, Dr. Copeland?
We have gained 40 years of life over the course of this century. But if we were sitting around now in 1900 and we were saying, what are our big targets, what are our big challenges, what do we need to do, we would have not guessed many of the things that have come up over this century that we've had to deal with and that have ended up being health problems. In 1900, we would have named infectious diseases, workplace hazards, safe pregnancies and childbirth, and we've done a terrific job at controlling those in the United States over these years, amongst other things. But some of the things we wouldn't have anticipated were the tremendous toll that tobacco would have taken on our health, the role of automobiles and collisions and injuries and deaths from those over this century. We wouldn't have considered dental health to be something to concern ourselves with. And so we can't be so smart now as to say we're going to anticipate all the things that are going to come up, because many of them are our own making. And so human behavior plays a huge role in our health, in our dealings with disease, and our avoiding and preventing disease. The 40 years we've gained over the 20th century have largely been because of our efforts on prevention, not our efforts on cure.
We're going to ask our 3 doctors to stay with us. We have to stop for a moment, but when we come back, when disease turns doctors into detectives, emerging illnesses. Stay with us.
Probably you remember some of my home runs of the last season.
Today I would like to invite you to my real home, the Dominican Republic. Now it's your turn to swing the bat and hit the home run for the most memorable vacation of your life. Come to the Dominican Republic. All Americans are welcome.
The Dominican Republic. Come, share our treasures.
When you use the Kodak Picture Maker at Walgreens Photo Center, you can make the perfect gift in less than 5 minutes. You simply print directly from your photo. You can even improve your photos by cropping, reducing red eye, or adding borders and text. Even save your new print on a floppy disk to take with you.